class. Okay. So welcome to the lecture number 2 of compiler design. In this lecture, we will go through what exactly a compiler is, then overview on phases of compiler. So there are 6 phases. We will go through each of the phase briefly. And throughout the course, we will cover nothing else than these 6 phases. Okay. So what exactly a compiler is? So it is a system software which translates source language into functionally equivalent target language. Usually the source language is a high level language, whereas the target language is either assembly level or machine level language. So usually the target language is assembly level language. Why? It is easier to translate a higher level language into a assembly language than to translate a high level language into a functionally equivalent machine level language. So first the high level language is translated to an assembly level language, then by using an assembler, again the assembly level language is translated to a machine level language so the machine can understand. But what exactly a compiler is? Compiler is a system software which translates source language into a functional equivalent target language. So let us give you a simple example. Let me translate an English sentence to a Hindi sentence. So let me become a compiler who will translate the English text into Hindi text. So here you see, so first what I will do, I will go through the source file. So the compiler has actually two groups of pages. First one is called as analysis and second one is called as synthesis page. So in the analysis page, first what it does, first it checks or first it divides the source language and checks whether the source language is syntactically and semantically correct or not. So here, before translating the English to Hindi, first what I will do, I will check whether each character is valid or not. Then I will check whether each word is valid or not. Then what I will check, then I will check whether the grouping of words are valid or not. So I is a perfectly valid word, goes is a valid word, to is a valid word, but college, so here you see, here this is not a valid word. So what I will do, it will generate an error that unable to find the or unknown keyword or sorry, unknown Lexim college. So I have rectified the spelling of the college. Now it's a valid word. Every day is a valid word. So after that it will check whether the grouping of words, that is I goes to college every day. So here the grouping, there is a syntactical error. Instead of goes, here it should be go. So it will generate an error in I. You cannot use goes. So I will rectify this goes into go. So now you see I go to college every day. Now it is syntactically, semantically correct English statement. So I can easily translate this one into Hindi. Similarly, I is a correct word, eat is a correct word, rice is a correct word. Now, this grouping of words I eat rice is a valid construct in English language. So first what it will do in the analysis phase, it will break the source language into constituent pieces and then it checks whether the grouping of the pieces is in according to the source language or not. So after the source language is correct, so if there is any error in the source language, it will generate an error. So you see, while you are translating a C program into a machine program, what you are doing, you are compiling the C program. So in the C program, if there is some syntactical error, then your compiler generates syntax errors so that you rectify those syntax errors. So after all the errors in C language is removed, then your target language is generated. So similarly, here while translating from English to Hindi, first I will check whether the English text is correct or not. If it is correct, then I can translate. So in the analysis part, what we will do, we will break the source program into constituent parts and check whether it is syntactically and semantically correct according to the language or not. And then in the synthesis part, we will translate the source text into the desired target text. So here you see, after the analysis part is over, in the synthesis part we have translated the source code into target code. मैं रोज कॉलेज जाता हूँ, मैं भात खाता हूँ. So here you need to remember that first what it checks whether each character is valid or not. Then after that it scans character by character from the source program and groups the characters into words. Then it checks whether that word is valid or not. Then after it checks all the words are valid, we are checking whether the grouping of words are valid or not. So once everything is fine, then we are starting the translation process. So the same process we will use in compiler. So next let us go through the phases of compiler. So you know that a compiler is a system software which translates a source program into a functionally equivalent target program. So let us go through what are the phases of compiler. So a compiler consists of 6 phases. One is lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization and code generation. And you see in every phase we are having an error handler. Every phase is associated with an error handler. So if in any phase an error is occurred, the error handler should handle that error and should provide informative message to the programmer so that the programmer can rectify the error. And here there is another thing, that is symbol table. So symbol table is a data structure which keeps track of the scope information of all the names present in a program. So you have written a program, suppose you have written a C program, within that you have written a function. Suppose within that function you have declared a variable A, and that variable is only visible within that function A. It cannot be visible to the main function. So these informations are called as scope information. So to keep track of scope information, we will use symbol table. So for each phase, so analysis, syntax analysis, semantic analysis, lexical analysis, intermediate code generation, code optimization, code generation, symbol table, error handler, each one is a chapter in compiler design. So we will go through all the things in detail. So these 6 phases are grouped into 2 groups. One is analysis phase. So the first 3 phases are analysis phase and the second 3 phases are synthesis phase. So let us first go through what we will do in analysis phase. So we will go through all these phases by through one example. Okay. So a compiler is composed of several components called as phases. So each performing one specific task. The complete compilation process is divided into 6 phases. Those phases are grouped into 2 parts. One is analysis, another one is synthesis. Similarly, as I have given you one example while translating English to Hindi, the same thing we will do in the compiler also. So now the analysis part, it is also called as front end of the compiler. So in this part, the source program is broken into constituent pieces, as I have told you in the example while translating English to Hindi. So first we have checked whether the characters are valid or not. Next we have checked whether the grouping of characters, that is words, are valid or not. Then we have checked whether the words, grouping of words, are valid or not. So in analysis part, the source program is broken into constituent pieces and imposes a grammatical structure to create an intermediate representation. So after the analysis part, what we will get? We will get an intermediate representation. So in the analysis part, it detects that whether the source program is syntactically ill-formed or semantically unsound. It means whether there is any syntactical error or semantical error. So if there is any error, then it must provide informative messages so that the user can take corrective actions. So while you are translating your C programs into an equivalent target program, you see, first if you are having any error in the C program, then it generates informative message, semicolon is missing, undefined variable, like that. Okay. So that the user can rectify the mistakes, then it will translate it into functional equivalent target level language. So now the analysis part also collects information about the source program and stores the symbols in a table that is called as symbol table. So you see, suppose you have declared a variable in a user defined function, let's say BBSR. So in that, suppose you have declared a variable A, and that should be visible only within that function. It will not be visible to other functions. So this information is kept inside the symbol table. Okay. So the analysis part can be done in 3 sub-phases. One is lexical analysis, syntax analysis and semantic analysis. So after the analysis part is over, means after the source program is correct according to the syntax and semantic of the source language, we will go for the synthesis part. So in the synthesis part, what it will do? It will construct the desired target program. So in analysis part, we have checked the source program, whereas in synthesis part, we will we will construct the desired target program from the intermediate representation. So you see in the analysis phase, in the analysis part, it produces an intermediate representation. So that intermediate representation will be taken as input to the synthesis part. So it will construct a desired target program from the intermediate representation produced from the analysis phase. Okay, and information stored in the symbol table. So the synthesis phase consists of three phases. One is intermediate code generation, code optimization, and code generation. So let us go through all the 6 phases briefly by taking an example. Okay. So let us take a small statement of a C program SI equal to PTR by 100. Let us say that we want to compute the simple interest if the principal amount, time period, and rate of interest are given. So I have taken a single statement from the C program and I will tell you how this single statement is processed by all the phases of the compiler. So let us first go through the lexical analysis. So the first phase of compiler is called as lexical analysis. It is also called as scanning. So the lexical analyzer scans character by character from the source program and groups the characters into meaningful sequences. So you see, while translating the Hindi to English to Hindi statement, what we have done? We have first checked whether the characters are valid or not. Then what we have checked? Then we have checked whether the grouping of characters. So here also the lexical analyzer first scan character by character from the source program, then groups the characters into meaningful sequences. So the meaningful sequence is called as lexeme. So then checks whether it is a valid token of the language or not. So here there are two terms, one is lexeme, one is token. So lexeme means what? Sequence of characters. It's called as a lexeme. What is a token? Token is the smallest indivisible part of a program. So in any programming, you will find 6 kind of tokens. One is keyword, identifier, operator, separator, literal or constant, and comment lines. So first it will scan the program character by character, then it will check, it will group the characters into meaningful sequences called as lexeme, then it will check whether that lexeme is a valid token or not. For example, here let me write a simple sentence, integer x1. So you see, so first it will scan one character, then it will scan one character, then it will scan one character, then it gets a separator, then it will group the characters into a meaningful sequence. So this is called as lexeme. Okay. So now this lexeme belongs to which token? Int is a keyword. So int will go to the token keyword. Okay, so I hope all of you have understood lexical analysis. So you see, instead of int, suppose someone has written tni, so it is not a valid token of the language. So what it will do then, if the lexeme is not a valid token, then it generates an error handled by the error handler. But if the lexeme is a valid token, then what it will do, it will form each lexeme, it will produce output as token name, comma, attribute name, attribute value. Okay, so let us go through the running example SI equal to PTR by 100. So first it will scan character by character. So S is a character, I is a character, next it gets an operator. So it will group these characters into a lexeme SI. So this lexeme SI is an identifier. So it belongs to the token identifier. So it's a valid token. Valid token means what it will do? It will group it into attribute value, comma, token, or token, comma, attribute value. So SI is an identifier. Then it will again scan another character equal to. So equal to is an operator. P is an identifier. Star is an operator. T is an identifier. R is an identifier. Division is an operator. Then 100 is a literal or constant. So I hope all of you have understood lexical analysis. In lexical analysis, what it does, it scans character by character from the source program and groups the characters into meaningful sequences called as lexeme. Then it checks that lexeme is a valid token or not. So if it is not a valid token, the error handler will generate an error so that the programmer can take corrective actions. If it is a valid if it is a valid token, then it will produce a pair in the form lexeme and token. So what is the input to the lexical analysis? The source program is the input to the lexical analysis. What is the output from the lexical analysis? The output is nothing but a stream of tokens. Okay, now let us go through the next phase, that is called as syntax analysis. So in lexical analysis, what we have checked? We have checked whether the words or whether the leximes are valid token or not. So you just recall the example of our English to Hindi translation. So first we have checked whether each character is valid or not. Then we have checked each word is valid or not. Then what we have checked? Whether the grouping of words is valid or not. Similarly, here in syntax analysis, what we will check, whether the grouping of tokens, words or in programming language we will call it them as tokens, whether the grouping of tokens are valid or not. So the second phase of compiler is called as syntax analysis, or this is also called as parsing. So the parser or syntax analyzer gets the string of tokens from the lexical analyzer and checks whether the combination of tokens is in accordance to the grammar of the language or not. So if it is in accordance to the grammar of the language, it will generate a parse tree. Otherwise, it will generate an error that will be handled by the error handler. So if the combination of tokens is not in accordance to the grammar of the language, it generates an error that is handled by the error handler. Otherwise, it produces a parse tree. So let us go through our running example. So here you see we have taken SI equal to PTR by 100. So SI is SIPTR, these are identifiers. So I have renamed them as SI to ID1, P to ID2, T to ID3, R to ID4. So now we will generate a parse tree. So you have already studied this one in your data structure subject, how to construct an expression tree. So this is an expression, so its corresponding equivalent parse tree is nothing but an expression tree. So first we will prioritize the operators. So first precedence, second precedence, third precedence, then equal to fourth precedence. So first we will start from the operator having lowest precedence. On its left side we will keep SI. Then on the right hand side, this third precedence, that is division. So division will have a left child and a right child. On the right child we will have 100. On the left child we will have PT into R. So from PTR, first we will go through multiplication. So multiplication's right hand side we are having R. Multiplication's left side we will have P into T. So start P and T. So the same thing I have written over here. Instead of SIPTR, I have just renamed into ID1, ID2, ID3 and ID4. So I hope all of you have understood syntax analysis. We will go through this one in detail. So there is a chapter for syntax analysis. So you don't worry. Okay. So you just understand what is its objective and what that are done in syntax analysis or on all the pages of the compiler. We are going briefly. Okay. In detail we will go when we will go through this chapter. So next we will go through semantic analysis. So the semantic analyzer uses the syntax tree. So you see the syntax analyzer produces the syntax tree or parse tree that will be taken as input into the semantic analyzer. So the semantic analyzer uses the syntax tree and the information in the symbol table to check the source program for semantic consistency with the language definition or not. So now you see semantic consistency means, suppose I have written one sentence, integer x equal to 5.2 modulus 3. So now you see int is a valid token, x is a valid token, this is a valid token, this is a valid token, modulus is a valid token, 3 is a valid token. So the grouping of the tokens int x equal to 5.2 modulus 3, the grouping is also correct. So there is no syntax error. But there is a semantic error. What is that semantic error? Modulus operator cannot be applied on floating point type. in C programming. Okay, so there is a semantic error. So the semantic error checks what? A semantic analyzer checks what? It checks the, or it gathers the type information and saves it either in syntax tree or in the symbol table for subsequent use during the intermediate code generation. So now you go through this one. An important part of semantic analyzer is type checking. Here you see the modulus operator cannot be applied on floating type. It checks the type. Okay. So where the compiler checks that each operator has matching operand. Okay. So similarly, let us go through our running example. So here SI equal to PTR by 100. So now if SI is float, whereas P, T and R are integers, so all these integers by 100, 100 is an integer, so integer by integer will generate an integer, and you may lose the precision over here. So what you will do? It's better to take, instead of 100, if you will take 100.0, or if you will use a type conversion over here, if you convert 100 to a float type, then integer by float will give you a float. You will not lose any information. Okay, so here in the parse tree we have saved the information that while applying in 100, we will first convert it into float, then we will apply, so that the information will not be lost. So this is the job of semantic analysis. So next we will go through. So you see we have gone through the first three phases: lexical analysis, syntax analysis and semantic analysis, which checks whether the source language is correct or not. So once the source language is correct according to the rules of the or grammars of the language, then we will translate it into target language. So that we will do in the synthesis part. So the synthesis part's first step is intermediate code generation, or it is the first step of the compiler. So it takes semantically consistent parse tree as input. So what is the output of semantic analyzer? That will be the input to the intermediate code generation. So it takes the syntactically consistent parse tree as input and produces an intermediate representation of it. So why it produces intermediate representation? So that it is easier to retarget the code and allows some optimizations to be carried out on that code, which would not be possible. If we will not make an intermediate representation, it is not possible to make some optimizations, and it is not also possible to generate the target code. So an intermediate representation is produced in the intermediate code generation phase. So there are basically three types of intermediate code representations. One is postfix notation, syntax tree and tree address code. So you see there is a dedicated chapter for intermediate code generation. So we will study all these things in detail. So right now I am just briefing these things. Okay. So let us go to our running example. So here you see the intermediate representation. There are three kinds of intermediate representation: postfix notation, syntax tree and tree address code. So in this example, I will give you the tree address code for SI equal to PTR by 100. So you see SI equal to PTR, then 100 I have converted it into float, so that there will be no loss of information. So here you see what should be the intermediate representation of this one. So first we will convert integer to the 100 integer to float. So first we will convert integer to float. So now you see T2 equal to ID2 into ID3. So the intermediate representation will have the form A equal to B operator C. So why it is called as tree address code? Because you see there are three addresses A, B, at next three address A, B, C. So it should be in the form A equal to B operator C. So now you see first we have converted it into float. Then what we have done? ID2 multiplied by ID3. So this one will be done first. ID2 into ID3. So T2 in T2 we have stored that one. Next what we will do? So this is nothing but P into T. ID2 into ID3. Next what we will do? We will multiply the resultant into R. So R. So this is T2. Okay. So T2 into R. So T3 is nothing but T3 equal to T2 into R. R means ID4. So we have done this one. Next what we will do? Next we will divide it with 100. So T4 equal to T3 by T1. So T3 equal to T3 equal to this much. This is nothing but T1. So this is T3. So T4 equal to T3 by T1. So T3 by T1. Next, ID1 equal to T4. So ID1 will store the resultant value that is on the right hand side of the tree. Okay. So this is T4. So this is how we have generated the 3 address code. So why we are generating the 3 address code, or why we are going for an intermediate representation? So that we can easily translate it into assembly code, and then we will translate it into machine code. Okay. And if any optimization may be applicable, then we will apply those optimization also, so that our code will execute fastly. Next, let us go through code optimization. So what is code optimization? In code optimization phase, we will attempt to improve the intermediate code so that better target code will be resulted. So usually better means faster. So if you can reduce some steps, then it's better you reduce it. Okay. So a good compiler should optimize its code so that it can execute fastly, so that the time complexity of the running time complexity of the code will be less. Okay. But some other objectives may also be desired. For example, shorter code or target code that consumes less power. Okay. So if you are designing a program, or if you are writing a program for a network enabled service, then it's better you write the program in such a way that it will consume less power. Okay. So next, a simple intermediate code generation algorithm followed by code optimization is a reasonable way to generate target code. So we will go through this one in detail when we will go through code optimization chapter. Okay. So now let us take our example. So in our example, what we have taken, SI equal to PTR by 100. So 100 we have translated into float. So here you see into float, we are doing a type conversion. So why we will do a type conversion? If we want to optimize the code, rather than doing type conversion, take the 100 as 100.0, so that automatically we will not consider 100 as integer, 100.0 is in float or double value. Okay. So we can eliminate that step. So you see in the previous example we have in the previous example, the first step is T1 equal to into float 100. So here what we will do, we will eliminate that one and we will directly do T4 equal to T3 by 100.0. So translating or converting 100 to float is useless. So better directly take a floating point value. Okay. So here we have reduced one step, that is we have optimized the code. So similarly, we will study some machine dependent and machine independent code optimizations when we will go through the chapter code optimization. But I hope all of you have understood what is code optimization and how we can do it. We will study that. Okay. So next is code generation. So the code generator takes as input an intermediate representation which is optimized intermediate representation. So intermediate representation is produced from intermediate code generation, that is optimized by the code optimization phase. Then we have got the, actually here I should have written on optimized intermediate representation of the source program, and then maps it into a target language. So now you see in our example what we have taken, SI equal to PTR by 100, or we have taken SI equal to PTR by 100.0 after it has been optimized. So what is our first operation? T2 equal to ID2 into ID3. So ID2 must be transferred into a register and ID3 must be transferred into a register, so that we can apply multiplication operator. So first here you see move ID2 into R0. So ID2 into R0 means what you will do? ID2 will be transferred to the register R0, and this is an integral operation because we have assumed that ID1, ID2 and ID3 are integer, whereas 100 is a float, and SI simple interest is also a float. So first we have transferred ID2 into R0, then we have transferred ID3 into R1, then we are doing the operation mul R0 into R1. So mul R0 into R1 will do what? It will store the value, it will multiply R0 and R1 and it will store the value in R0. Next, MOV R1 comma ID4. So ID4 will be transferred, means 100.0 100 will be transferred to R1. Okay, then mul R0 comma R1. No, sorry, ID4. Let me go through the previous example. ID4. So ID4 is not 100. Okay, so ID4 is nothing but PTR. So R is ID4. Okay, so first PT is multiplied, then PT is multiplied with R. So ID4 is transferred to R1, then PT which is stored in R0 is multiplied with R1. So mul R0 comma R1 is nothing but R0 into R1 and the result will be stored inside R0. Then DIVF, so it is a fractional division. Okay, R0 comma 100. So R0 stores PT into R, so PT into R by 100.0. So it will be stored in R0. So you see R0 equal to divf r0 comma 100.0 is nothing but r0 will be divided by 100.0 and the result will be stored inside r0, which is a floating point operation. And finally we will assign ptr by 100.0 to s. So s equal to ptr by 100 we have taken, s equal to p into t into r by 100 we have taken. So first we have computed this much, then so basically after code optimization 100 will become 100.0. So first we have computed this much, then we will transfer this one into s, so which is nothing but id1. So r0 will be transferred to id1. So this is how we have generated the code. So I hope